So it's basically if we're talking about I'm not sure if we're gonna get too much into the weeds, but it's in reality it's the metrics API. As long as the it's something implemented that metrics API, HPA can read those
Okay.
external metrics.
And the Prometheus adapter happens that it's a project that it gets data from Prometheus and then put it into the metrics API. I have done work with this many years ago. I think it was an OpenShift, and it gave me such a headache. This project, I don't know if it's better now, but in terms of like, it's a piece of code that the enterprise, right? In this case, the enterprise end user has to like adopt and run and configure and get HTTPS authentication, authenticate against the Prometheus adapter just to run this piece of code. It took me like a full week. And then I was trying to scrape Istio just to come to an HPA. I'm going to show it, right? That you have to expose it as a single metric here, right? Then it gets
Yeah.
exposed like this, and then it's something that you can read. Maybe that's one of the reasons the KEDA project got created.
Yes, exactly. So this is exactly the point that I was trying to make in this chapter. Before introducing readers to KEDA, I wanted to make sure that people understood very well why going to KEDA was worth it. So in this case, you're right. If you want to go, HPA is capable of doing all of it, all of what KEDA does actually. It's using external metrics. You can configure those metrics by yourself. You, Carlos, have done it. But KEDA, what it does is actually helps you on that. So with HPA, you can configure this. You can configure external metrics, anything that you would like to use. You can write it. And this specific example or the lab that you're looking after, it's basically trying to address that so that you can actually use a different metric than CPU and memory and scale your HPA object. No problem with that.
Yeah, but it's something custom, and then like probably in open source on the open source ecosystem CNCF, there was like only one implementation was Prometheus. But if you wanted to get metrics, I don't know, from a cloud provider, right, has an API or
Yeah.
CloudWatch or your custom thing for IoT, you have to figure this out yourself. And and the project was not that active. It was like, I think it's the same code from like eons ago. So the maintenance, I went when I was working with it, a lot of things were like outdated in terms of currency for the Go programs. So it was kind of difficult to convince an enterprise end user to just take this code, and sometimes just say like we're going to write something new because we will need to maintain it. So
Yeah.
um
Yeah.
but yeah, HPA at the beginning was designed with this narrow thing of like, if you can make a metric show up, it can be used. And it's there's not that many flexibility in terms also of target, right? Like KEDA, like for example, schedules, right? Or type of like logic. It was just the
Yes.
average.
Yes. Exactly.
And then the other thing you show in this chapter, just to move quickly, is the VPA. Um, that VPA is more for right, like loads are not spiky kind of thing, like you mentioned in the book, are more like they you're not sure. Also, VPA is used as a testing mechanism. I've seen in some places where they put it just to investigate over a period of time, collect like because right, it has a different controllers. That is, one is monitoring, the other one's applying.
Yeah, so basically VPA, you can use VPA depending on the application that you have. One example that actually I put in the book is a database. Unless it's a reading replica, you can scale out horizontally. But if not, you might hit a point of or a limitation where you actually need to add more resources if you want to give more power to it. Of course, there are other mechanisms, there are other strategies to address that challenge. But just for the sake of giving an example, that a database, it could be a monolith that or a legacy application that is not written in a way that it can scale out horizontally. So the only way that you can um, send more load or make that application to do more is to add more resources. So that's why BPA comes into play. It basically just gonna can adjust the pod automatically by adding more resources to the pod, or like you were saying, it can just monitor and give you kind of like a dry run, so to speak, to what the resources will look like or should look like based on the pattern that it learned.
Yeah, some applications like stateful applications that are storage based, right? Things that don't scale like web apps, like stateless. So
Yes.
like Kafka, your RabbitMQ, your database, your Postgres, your MySQL, all those things, monolith, and also applications you mentioned applications that cannot um, be stateless. Like they have a lot of state. They load when they boot up. They load a lot of information either from a database or from Elastic Cache, and they have that information hot to have low latency, but they cannot create another replica because that would increase latency. So they prefer to have everything in memory.
And
Yeah.
also licensing, right? Sometimes you can't.
Yeah, CPU. Yeah, some licenses are based on cores, so they prefer to use the core and not jump to a different core, or maybe potentially that pod lands in a different instance or a different server, and they're restricted. Yeah, that's a good thought, Satish. Um, and then this
And,
is the things that you
and one
mentioned.
thing is,
Go ahead.
I think with VPA, you need to restart, right?
Yeah, that's what I was going to say here, right, Christian?
That's
On the
exactly,
restart.
yeah, exactly. You can get it. You actually hit the right paragraph. It has the auto mode, so to speak, where you can a BPA is gonna change the pod automatically. Actually, the lab has one that on that, but now with the recent version of Kubernetes, you can apply the in-place resize, so that can be done automatically without recreating the pod. So before this change, what BPA will do is that it will change the pod, and that will cost to create a new pod with the new resources. So that will, of course, will cause some
Yeah,
downtime.
I think you had a diagram. Let me see which page it was.
Which version you mean? This is introduced in Kubernetes?
1.33 started.
33.
As
Okay.
alpha,
Yeah,
yeah, and
yeah.
136 will have it as, yeah, 136 have it stable, right? Default
Yes,
and
yeah,
enable.
yeah, yeah.
So uh yeah, I think the solution of allowing the pod to be mutated, right? That section, because other
Hmm.
sections like annotations can be mutated, but that section of like requests can be mutated now in place. But there were no, I think there was one project from Google that they did for like monitoring behind the scenes and created something, but now the VPA, the actual VPA, got support for it. um,
Yeah,
yeah, this is the architecture of VPA. The VPA recommender, the VPA updater is the one that will go ahead and update the pod via stateful set or deployment. Basically, that's what it does. It finds the parent, or you specify the target. I think here, right, the target ref.
yes, yes. You
What?
specify, yeah, yeah. You specify which object this will apply to. Usually, that applies to a deployment or a job.
Okay, and
So,
then
Christian,
go ahead.
in 136, right? Uh, there is no downtime at all, like it because it doesn't restart.
Yes, yes, exactly, exactly. It comes enabled by default, so yeah, it won't cause a downtime.
Oh,
Yeah, and it has like how has like policies on how you want to be updated, if by a factor of something or a
oh,
precise amount.
okay.
Yeah, I don't know
So
if
does this mean less pod disruption budget config, or I don't know. I think pod disruption budgets was to protect, critical pods as well. Now with this recreate being not recreate, sorry. What
In
was
place,
it?
yeah, in
Yeah,
place,
yeah.
yeah.
Not recreate, yeah, or auto. I think in place pod vertical scaling. I think we're not going to lean onto pod disruption budgets for this purpose that much.
To be honest, very few customers that I'm aware of use VPA in auto mode. So I guess that the PDBs were related to deployment rather than letting VPA to update. Maybe I was not exposed enough to a customer that was using this in auto mode.
But yeah, in terms of PDBs, they're still really applicable because they're more on the upgrade side. When you're going to rotate the image, regardless if VPA is like what's going to do a change to the deployment or you're rotating, you want to do it in a way that you make sure that you have enough replica based on the business need, right? And you do it in a respecting the PDBs.
Yeah.
And for some, I was going to complain that like Kubernetes didn't put something in validation webhooks to check if there's another PDB targeting the same deployment. That's kind of everybody writes the same policy over and over, or puts kernel because there might be two teams or two people or two YAML files pointed to the same deployment, and you end up with two PDBs. That's kind of like the only thing I can remember about PDBs being a pain, and also like not enough. Yeah, here actually, that's what Sevin was mentioning, right? In here, the PDB limits the difference containers or create a PDB would be less aggressive if you're dealing with critical applications. So it will protect you from the VPA doing that recreation, deletion, right? I'm mutating to get new pods. You have 100 pods, you get 100 pods, right? Back with that new size by the VPA. But thankfully now the VPA is in place with all the caveats of like increasing a pod request and then how many other pods are there, if it's still space left, like does like you didn't have it, like you move some of the problems around. That was
we have Saif. Yeah, he has a question.
Saif?
Yes. Hey, the question actually is like a more generic, is like why would we use VPA like and not HPA only? Because VPA is kind of I wouldn't say annoying, but it's kind of hard to scale because you have to scale up and down the same pod, and you might cause problem to other pod, and then they might get evicted if the node does not have enough resources which you expected to go up to, and then there are other pods that might get evicted. Unlike the HPA, which is like it adds a pod, but before it adds, it checks if there is enough space.
To fit in.
Agree. Yeah, actually, to close chapter 3, I covered that specifically. I agree with you that VPA and using VPA and HPA for scaling the same pod and the same metric will be very problematic.
Yeah.
If at some point someone is willing to continue using that, the recommendation will be to use a different metric at least, right? However, the pattern, that's what I was saying before. I have not worked with a customer that has used this in auto mode. What I've seen, on the contrary, is that they've been using VPA for understanding how the resources that the pods will need, instead of course, now we have, and actually I mentioned that in the book, the tools that you have available nowadays that use VPA under the hood only to as a recommendation. These are the resources that VPA recommends. And sometimes, depending on the application, VPA might say, hey, looks like that your application is only using 10% of the CPU. But you are okay with that because that's kind of like the minimum capacity that you can offer to your services. So yeah, it depends. And in any case, I will recommend using VPA to start learning what your pods will need.
Yeah. Because sometimes it's another alternative to do it with like what Christian recommends in the book, right? Prometheus, Grafana, your observability stack to understand like what should be that HPA values that you put in there. People got that advice, and from the community, I heard a lot of times just use a VPA a monitor, or use a tool that uses VPA under the hood, and then that recommendations come in, and we'll use the recommendations, right? Instead of trying to figure out the graphs, right? Maybe people don't know at that stage that, but the last one that your question is the last resource if you're going to do the recreate, right? VPAs are for things that are not stateless, basically like databases and things like that you cannot scale by adding another replica.
Yeah.
But yeah, start with HPA, but get the value monitoring, or VPA recommendations. Good question. And yeah, Christian added that at the end of chapter 3 on using it together.
I might be early to ask this question, but I saw the mention there. Carlos, you were highlighting third-party tools, one-click operations. At what stage a company should decide, oh, we've done everything at hand, open source or available by Kubernetes, and we should go look for a third-party tool, throw money at them? I don't know, maybe it's a bit earlier, maybe we discuss this after the KEDA bits, chapters. Up to you to bring it up.
So my point with that specific sentence is that, yeah, depending on where you are, you might not want to go through all of this pain or configuration or burden of configuring your VPA policies and trying to make this more predictable or in an automated fashion. There are already paid tools that can help you on that. And yeah, in production you might want to be more conservative, but in pre-production environment, I mean, I will go ahead and just click there and apply the recommendation and see how it behaves. If the recommendation made actually total sense, I can apply that recommendation to production, or that recommendation plus 10% or something like that to keep some headroom.
Yeah, there's a third party. I work in AWS and Christian, and we have like partners that have created solutions. Yeah. One of them that I did a couple of talks in CNCF and KCDs is Stormforge. There's other ones that would use AI or not AI. I think we can say machine learning, right? Like this is a problem of machine learning, AI, and we always like say AI, but it's a machine learning problem that they organizations have so many apps heavy, like thousands of critical applications, and to have the current team struggling with doing Kubernetes upgrades to say now you have to evaluate these 1,000 applications to optimize for performance, or what is the right utilization during the year for these 1,000 applications. They say like, well, buy versus like do, right? And they can say, well, it's at the end of the day, it's more cost effective to pay for a tool that would automatically, you get an agent installed in the system, and then some of the tools work the same way. Like they install an agent in the system that will start doing recommendations, and then basically say a VPA machine learning decision making type of thing, and then you say you want to apply or let it go, or even like to the point that we'll have GitOps configuration, but most people don't do that. I think the recommendation is always like do it something in place the same way you do HPA, right? You don't go back to say how many replicas you have. This is like the size of the pod to reduce the consumption, or basically the window between how much you requested, which was maybe that's usually the problem. People request gigs or a lot of CPUs, and they're wasting money, right? Where they should be requesting just enough to get the app running at the right thing to get the next replica to handle the next load.
Hey, Carlos, quick question. How do you even, like, if you're an application developer, right? How do you know what CPU, what memory you need? Man, you will just go with, yeah, like, yeah, 1 gig, 5 gig, who cares, right? You
No,
just
I
don't know.
care. I care
No,
if I'm
you
paying
do,
that bill. If
no,
if the boss is paying the bill, he cares.
no, but if you ask developer,
We don't ask developers. We ask platform engineers to take that app, put it through the system like Prometheus,
And
Grafana, Kubectl, and then we set the value.
okay,
let me
And
tell you what platform engineers do, because I have a team of them. They turn to the application developer and ask, what do you think your application does here? Because they don't have the context. So
Yeah.
I
Yeah.
think, it's a very good question, Satish. They just write something, app devs, to just throw it over the fence, like the
Okay.
old
yeah, and that's the problem being solved, right? With these
paradigm.
things.
Yeah.
Yeah.
But
Well, my hope with those platform engineers and everyone here is that they go and read a book
Yeah.
and go into the chapter 2 or 3, I think,
Yeah.
where I actually have a lab where I load test, and with Prometheus and Grafana,
Yeah.
you can actually take a decision on how much you need based on data, not just
Yeah.
guessing.
It's a teamwork. I think the answer, I was
Yeah.
kind of joking, but it's a teamwork, because if it's the developer cannot do the get that answer, because what Christian said, like they have to set up the observability of the app and then do a load test, right? Like simulate if your peak, if this app will never handle 10,000 customers or 10,000 users, then do simulate 10,000 users and see if this app is CPU bound or memory bound, and it will consume 1 gig or 2 gigs, and then that's, you get a ballpark number. But I would say what we were saying about VPA, you can install the VPA or a tool that constantly is in the cluster, give you recommendations as you go, because that happened with the load test, that you with the 10,000 users, and this application never got more than 100, right? So you did it on the worst case scenario.
by the way, it's a very broad question again. Once again, I'm coming with a similar question. Is there a good benchmarking tool for such tests in the cloud native space? I don't, if I haven't seen any. Like
For search test?
no vendor, no, just, I don't know. You have a Kubernetes application, you just want to give it a try and see, how it holds under some pressure. And when you change,
stress test,
like some benchmarking.
Yeah,
so a
Locust.
benchmarking.
There's a bunch of open source.
Yeah, Locust, K6.
Locust.
I use K6 in the book at the end.
K6? Oh, nice. Thank you. I actually haven't tried myself one, so.
Yeah, I see Locust a lot, and then the one that Christian mentioned for artillery.
Yeah.
Artillery is the name of the other one. I think artillery.
Artillery?
Yeah.
Let me see.
Wasn't no. But I think that's just like the runner. There's some software and they're open source that will give you the whole like graph of like the load, and then schedule it like a little bit more like a tool what you're like more complete, right?
Yeah, Locust gives you that dashboard when you run it.
Yeah. Can somebody look up the website? We can share the. I can never spell it.
Locust and K6.
Nice.
And it's locust.io, and it's open source.
Also for before we change topic, for the monitoring or the tool that I mentioned in the book, Goldilocks, it's open source as well, and they use VPA for
under the hood. Like Goldilocks will give you the recommendation. If someone can put these links in the notes, I appreciate it.
I can like that. Yeah.
Yeah. So Goldilocks is very popular for many years. I think since I started Kubernetes, everybody was using that as like it's a recommendations, right?
Mm-hmm.
And it's based on VPA.
Hey, Christian, quick question. Once this VPA becomes mainstream in 1.3.6, right, where you don't have to recreate, right? So far in the book, your recommendation is always your first preference is HPA, right? So
Mhm.
that, right? But once VPA, where you don't have to recreate, then why even bother with HPA, right? Just go with VPA and just deal with it, right?
No,
No.
actually, I will go with keep working with HPA. Because sometimes, not to attack anyone here, but for me, if you need to keep using VPA to scale vertically, for me, it's a bad smell of the architecture for the application or something that you might need to work on. I will always recommend to scale out horizontally, adding more nodes
Yep.
than going vertically.
Yeah, and it's that place is explained, I think, in chapter 1 of like what is horizontal scale, like why you want to do it, why you want to have multiple replicas of the stateless application for beam packing, for flexibility of in and out, like really quickly go down into minimum usage and then handle spikes. So there's I think that the
Also,
first
also
HPA.
yeah, as Saif was saying as well, you might VPA might tell you, hey, it needs more resources, but guess what? The node or doesn't have the resources that you need. So there's
Yeah,
nothing you can do about it.
yeah, you can pay more and then switch the instance for a bigger one until you run out of money if you're in copyright paying for that. But if you're
By the way,
hardware bound,
yeah, I asked about the third-party tools because I think every company has a sweet spot of, or yeah, they might be, I think it depends, like trade-offs are different, so they might not be there to spend some money on a tool, even though it's production, even though they have,
Mhm.
big lot. They might want to lean onto their, I don't know, cloud vendor or
Yeah.
existing tools. But yeah, it was just a hypothetical question for you.
it's perfect.
This VPA does respect limits, right?
Yes.
Yeah,
Yes.
there's
Yeah.
in
Yeah.
the
Yeah.
policy you
Yeah.
saw, like you can tell it like, hey, you can give it the recommendation should not be higher than X, right? And those type of
Yeah.
things. I'll stop sharing. Christian, can you share? And then we'll do a couple of demos to
Sure.
show KEDA, and then maybe the next session we'll go deeper into explaining how KEDA works. But I think you have some use cases on scaling that is not like CPU and memory, for example.
Exactly. Exactly. All right. So usually what is gonna go when you read the book, of course, it's gonna guide you into what KEDA is. But I guess that we've been reframing that little by little, but just for the sake of doing it today, KEDA is a controller that is gonna work on top of HPA. Right now, right now things might change in the future. Right now, KEDA works on top of HPA. So the topic that we mentioned before around the custom metrics from HPA, KEDA takes that burden and expose that through autoscalers or scalers. Right now, I think that, not sure if I find it really quickly, but at the time of writing, KEDA had like 70 scalers, 70 plus scalers. That includes, of course, Prometheus, cloud provider, metrics, Kafka, and things like that, so that you can just wire that up on your scale object, and that's it. You don't have to install anything. The good thing about this project is that the maintainers, when someone requests or pushes a new scaler, they require for the authors to include automated testing, because they got to a point there too many people who was adding scalers there, and the maintenance had to rely on those 3-4 people that were always the core maintainers, so they have to do it. So one of the benefits that used to be a highlight, maybe not that anymore with KEDA, is that with KEDA you can scale from 0 to 0 as well. So there are two phases here. There is an activation phase where KEDA will activate the deployment, going like, hey, now you are active, you're gonna scale from 0 to 1. Now from 1 to n or to x, it relies on the policy that you configure in the scale object, right? So I'm going really quickly into that because I want to show you the demo. And that was the important part, right? The first one that I would like to show you is basically how you can scale up with using a custom metric that is not going to be CPU or memory. And this is kind of like a rewrite of the lab that Carlos was showing before when using custom metrics, that it was using latency to scale. So for this lab, you basically are going to be installing KEDA. And based on the history that I have here, you can see here that when you install that with Helm, you will get 3 controllers: the admission webhooks, the operator, and the operator metrics. These controllers are going to be in charge of different things, and the admission webhooks, it's simply just a validation that when you create the scaled objects, they don't interfere with each other. There are a few other validations that are gonna tell you, hey, you cannot create this object. So I think it's a really good component. The operator metrics is basically the one in charge of dealing with the metrics with different scalars. This and the operator here, the main brain of KEDA, are the ones that are gonna take charge of scaling your application. Be aware that the team is actually changing the operator and operator metrics and how they work. They might end up having only one controller because they have noticed that when a cluster goes at a really high scale, things can get messy and the performance can degrade. And what they're aiming to have is to scale as soon as possible and be these KEDA and the HPA objects to be the less disruptive as possible, right? So be aware that this could be changing, and I think that they're working on changing it, and they improve that. So maybe the information that you're gonna find in the book might be not up to date already, but this is kind of like the.
But today the operator is all in controller work, but the data plane, like data intensive data plane will be the metric API server, right?
Yeah, exactly.
Okay.
Exactly.
And all the scalars, I'm guessing, are compiled in Go into that little API server container.
Yes, exactly.
Okay.
Exactly. All right. So yeah, well, I installed a few things for the other demo, but let me go over because I just wanted to show you that, and I'm gonna start with the first one. I'm gonna deploy. Let's see what I have here in the namespace. All right, so I'm gonna delete all the deployments, so just so that you can see how it works in when we're scaling from scratch. So I'm gonna go and deploy on the chapter 3, 4 actually. API, it's gonna be this one, and the Monte Carlo deployment. And one thing that I want to showcase here that is included in the book in the first 2 chapters is that when you have that deployment, if you pay close attention to this, there are no replicas. There is no replicas field here. There is no replica fields because now you are leveraging that responsibility to KEDA and HPA. If you have the replicas, for example, here like 1 or 2 and 5, when you deploy it and then after you deploy the scaling objects, of course, there's not going to be a problem. The problem will be when you need to update your application and you rewrite the deployment manifest with the replicas that you have in the YAML. It will, of course, if you have one replica, it might modify the deployment, it will deploy the deployment and will bring everything to one replica only. So the recommendation will be here to do not include it. And if you're in a GitOps, you just basically ignore that field to be updated. That may be safest mechanism if you're using the GitOps world.
Not specific to KEDA, but like HPA also. If you're using HPA, you don't put the number there because HPA is the one who will be switching that number.
Yeah, exactly. That's why, but by default, I don't think I have the latest of the latest version of Kubernetes. So if you don't have a replica, by default, it's going to be 1, right?
Yeah.
All right. So what I'm going to do right now is that I have Prometheus installed, get pods here in the monitoring namespace. I have the Prometheus stack. There are a few pods with error, but I think it's basically because they were crashing, but everything is operating right now, okay? What I'm gonna do is to deploy the monitor as we were talking about before. Let's do the monitor here. And this effectively, what it's gonna do is to simply monitor the deployment, the Monte Carlo deployment in this case. It's the one that I'm gonna be using across the whole book, right? And then what I'm gonna do is to deploy another object here, the latency object, which is gonna be the scale object. You can see here that it's very similar to an HPA rule. You have the minimum replicas. It could be 0, of course, and you have the Prometheus trigger. You have the Prometheus endpoint, the metric that you would like to use, the threshold, and this is very important. The query that it's gonna be KEDA is gonna be running to Prometheus to get the target value. And this is very important because, as Carlos was saying before, with HPA by default, it's gonna use the average, and you can play around with scaling on the metric on the percentiles. So it's not gonna be only about an average, because that could mean everything and anything. And you might want to say that, hey, only when you get like the 95 percentile reaching out this latency, it means that most of my pods are getting and reaching into that point, then start scaling, right? So that's another benefit of using KEDA as well. And I also have a load test here. So I'm gonna run it. And while I'm running it, I'm gonna go and monitor what I have here. Then I'm gonna show you the load test. You can see here that I have the Monte Carlo PI scale object that is not active. You can see here that it's active is false. It's not gonna be scaling yet. And you can see here the Monte Carlo deployment here. And if you see a metric coming here, this is the current metric, and this is the target of the scale object or the auto-scaling policy that you want. Right, this is self-explanatory: min pods, max pod, and replicas. As I'm stressing the pod right now, you're gonna see here that this number is gonna start to go up. And when it starts to go above 500, which is something that is happening right now, the scale object is gonna go into active. And there is a delay on the metrics that you can get here from the HPA object, but it's already active. So KEDA already started to work on that. And then it's gonna start to change the replicas as soon as it sees that it goes above that metric.
And Christian, just to highlight, I think there's so much, like, this is super simple, right? Like in 10 minutes, you explained how to properly meet an SLO, right? Like a lot of end users and enterprises, they have an API or a website, and the requirements is like it should be less than 500 milliseconds, right?
Yeah.
Or etc. So just by having a custom metric that checks the latency, it's enough to know, like, well, it will keep adding. It will keep adding replicas, right? More pods until you hit that sweet spot of meeting that SLO um,
Yeah.
target. But a lot of people, they think it's like this big investment on doing this, where actually it's very simple, right? You show it here.
Yes, yes. It's very simple, and you can see here that I'm not sure if it's gonna go faster on stressing the application. Usually it will take a few minutes, but we can actually go ahead with the other demo where it's gonna be more visible. Let me go ahead and go with scale to 0 and from 0. This is very easy to show. One of the benefits of using KEDA is that you can scale from 0 to 0. But it depends on where you want to use it, right? Maybe for your HTTP application, you might not want to or scale from 0 because you have to have an endpoint to reply to, right? It's not like a queue-based object where basically you have producers, consumers. So it doesn't matter if you don't have consumers because there are no producers. There's nothing to consume.
There's no
right?
work. Yeah, there's no work.
Yeah. But for HTTP-based workloads, you need at least one pod. However, I'm gonna just mention this because we're gonna talk about that in the next episode. With KEDA, it has an add-on, HTTP add-on, that you can use to that address this challenge. Without getting into the weeds too much right now, but it basically, when you have that add-on in place, it puts something in front of the service so that it always receive the request, and instead of making the request fail, it says like, hey, hold on, I got the request, but I'm gonna activate the deployment, so start scaling out, adding the capacity that you need, but hold on, when it's ready, the pod, I'm gonna send the request, so there's no failed request, but you will have some latency, of course, right?
Wait, that sounds like KEDA stole my idea of Knative. Like,
Yeah, yeah.
same concept. Yeah, it's something that you put the request freeze it until you can come up quickly with a pod, right? That container can handle it.
Yeah, there's a story around that I will
Yeah.
let the maintainer talk about it in the next episode.
Cool.
It's interesting. All right, so let me go ahead and continue with the next one, because I think that for this one, the load test is going to take a while. But let's go with scaling the application, the other application. You can see here that I have my deployment here, kubectl get deployment. You can see here that I have, well, actually deleted it, right? So I'm gonna go ahead and deploy the consumer. And if I go here and I deploy the producer as well, let me just be careful
so this is a
about not.
consumer reading messages from RabbitMQ.
Yes, right now, I'm gonna go here and deploy and read the. If we go to queue deployment here, the consumer, it's gonna be simply an application that is gonna be reading from a RabbitMQ. You can see here that application, it's gonna be connecting to the RabbitMQ. It's gonna scale, it's gonna request certain resources here, and the scale object is gonna look like this. And you can see here that it's gonna go and use the autoscaling queue that I have configured. And something very interesting that we didn't discuss before is that with KEDA, you can actually configure very easily authentication objects, because sometimes, yeah, the queue is gonna require you to log in AWS, Azure, GCP, or any cloud provider. They're gonna require you to have some authentication, and they separated that part because you can use multiple skill objects.
And can you go to the line that says target RabbitMQ? I think that's the trigger, right? Is it called the trigger?
Yeah. This one,
three.
yeah.
Um, yeah. So the trigger, that line 54, that's what is unique, right? Like what type of trigger, the type is all these scalars. So, and the other one was Prometheus. So you were connecting to Prometheus. So it was open, so you can like query it because it's demo. But in this case, it says RabbitMQ instead of Prometheus. So you'll be connecting to the RabbitMQ system, right? There's an admin API in RabbitMQ that you can say on this. I'm more familiar with Kafka than RabbitMQ, but I guess it's the equivalent of a topic or these messages. How many messages are in this topic? And then the settings that you see above is around like how often to go and query that information, right?
Yes. Yeah. Exactly. Yeah. How often do you want to query the queue, and how faster you want to, or slower you would like to scale down, and the maximum of replicas that you have here. I don't have minimum replicas. That means that it's gonna go and be 0. So if I go here and go again and watch the scale object spots and so on and so forth, you can see here that the queue consumer started to grow. And the reason for that is because if I go to this dashboard of RabbitMQ, you can see here that I think I had 150, and the elements or in the queue are going down and down little by little, and it's going very slowly, changing, consuming the messages in the queue. And the reason for that is that you can see here all the pods. KEDA said like, hey, you will need to scale out to the maximum capacity because the elements, the messages in the queue are not decreasing. So let's go to the maximum capacity and deploy the 15 pods, and
wow.
only one pod is ready
Today. But once all those ones go to running, they in parallel will start consuming the messages.
Yes, exactly. And why do you think they are pending, Carlos?
You didn't pay the bill to get more nodes, I guess.
You don't have more nodes. There's no component at this point in the cluster scaling out the nodes.
Yeah. That's you have a fixed number of nodes.
Yeah.
But if you want something that says, hey, that thing is pending, let me add a node to the cluster and join it. Could you run Kube ADM, right? Create certificates.
Yes.
All that stuff that you do for the CKA exam. There's controllers like the I think we mentioned at the beginning the cluster autoscaler and Carpenter.
Yeah, I agree.
I think we're at time.
Yeah.
They're going to stay in pending, right? That was on purpose.
Yes, that was on purpose. That was on purpose. They're gonna stay
Okay.
in pending. Just ready for the next topic.
Yeah, because
Well,
we talk about
it's gonna
this,
take
right?
a bit. It's gonna take a bit, but we're gonna address that.
Yeah, if we just had something that would auto scale nodes, right?
What could be?
Those pods from pending will be running.
Yeah.
And I think that's what we're going to pick up next on the next session. It's not going to be next week, but the week follow, right? And Christian will be with us on that. So thank you so much.
Well, just before going into the next topic, it's gonna be around. There are a few things on KEDA that will need to be that I would like to talk about, because the book covers that in chapter 5 and 6, and we might have a guess.
Oh, and then we have the guest. And I learned something new today about the HPA. So there's an HPA being created by the scale objects.
Yes.
Behind the scenes, right? But we don't on demand.
Yeah. You can see it here. HPA. This is the scale object, and this is the HPA.
I think that's something that is not known like from the beginning or obvious. Because Ali was not for me, right? I thought the controller was just doing the calculations and doing the work that HPA does. But I can see that basically you are like configuring the metrics API to expose only the thing that you care about, and then actually it'll be good at least for someone that like me, like I like learning by inspecting. I really want to inspect that HPA and then learn with different things, like what is like actually creating, right? And how does it look like? Because usually when you don't have KEDA, you do it by hand.
Yes. Yes. In this case, KEDA does it for you.
Yeah.
Mm-hmm.
Okay. Sebi, any last thoughts before we close?
No, I'm looking forward to doing our deep dive in KEDA, to be honest, and getting to meet the guest. I don't want to ruin the surprise for everyone else.
Yeah, this is a very interesting topic for those of you that are learning Kubernetes or are doing Kubernetes at work. Autoscaling / cost optimization is one of the top topics requested by enterprise customers all the time, because it's a constant way of like using Kubernetes correctly. Like the creation of Kubernetes and Docker was to efficiently have a full utilization of these Linux servers, right? And for some reason, it's so easy to create pods and put whatever size that you want that people waste money, right? On these things, and they should not. And also meeting the SLOs. I was trying to also like meeting a performance target, right? This API should not be longer than 200 milliseconds. This API, right? Those SLOs, these messages should be processed over the weekend. Should not be a month, right? Like how do you meet those business requirements? Translating business requirements into configurations of Kubernetes is a skill that is needed in the field. I think still it's not something that is obvious to everyone working with Kubernetes. So I'll let you with that. And thank you so much for everyone that joined, and thank you for everyone that watched this online. And on the next one, I'll send the new link to the new website, and hopefully everybody could be able to join. Okay.
Fingers crossed.
Thank you so much.
Cheers.
See you. Bye.
Have a nice evening. Bye.
Have a nice evening.